Hello, and welcome to today's lesson. We're going to be covering topics under the Standard 1.3 in 7th grade, and we're also going to be covering topics under the Study Island lesson, Linear Inequalities. And this is going to be very similar to the lesson that we did on linear equations, only we're going to be dealing with inequality symbols, less than, greater than, less than, equal to, greater than symbol, instead of an equal sign. So as always, remember as we're going through these problems, please be taking notes. They're only going to help you, and they're going to help you remember more, and they're also going to give you something to reference when you are doing problems on your own and studying. And also, you can always pause at the beginning of a question that I'm working out, work the problem out yourself, and then watch the video to see if you're getting the problem right or if there's some place you still need to be working on, and you can work on that area and study that area. So I'm so glad that you're joining us today, and let's go ahead and take some notes.
In 7th grade, our linear inequality problems are only one step. So if you did the equation video, they were 2 steps. So you typically had to do addition and subtraction, and then you did either multiplication or division. With one step, you only do one. So if you have an addition in the problem, you do subtraction. If you have subtraction in the problem, you do addition to undo that. If you have multiplication in your inequality, you do division to undo that. And if you have division, you do multiplication to undo that. And one other thing we're going to need to know in order to solve these is sometimes they'll give us the answer graphed on a number line instead of as written out and as an inequality like you see here. So if it's an equal sign, you just put a dot over the number it's equal to, which is 3 here. If it has a greater than or equal to, that's going to be a closed dot and shaded up. If it's a less than or equal to, it's going to be a closed dot and you're going to shade down, smaller, less than. If it's just the greater than symbol, you're going to have an open dot and you're going to shade up. And if it's just the less than symbol, you're going to have an open dot and you're going to shade down. So that's how we tell the difference between the greater than equal to, less than or equal to, greater than, and less than symbols on a number line. So this first problem here, we're going to be solving an inequality. And I'm going to go over here and just rewrite it so that we have room to work underneath of it. And so when we're working here, I see I have an x with a 2 being added to it. So to undo that addition, I'm going to subtract 2 from both sides. And these 2's cancel out, and I'm just left with x is less than, and 4 minus 2 is 2. So that's going to be my final answer, which is C. Number 2, I have 6 is greater than 2 plus x, and I just rewrote that so it's easier to work with on the screen. And so now I have to solve for x. Well, my x, this time, it's on the right side of the equation, which is fine. Once again, I have this add 2. So to undo the adding 2, I'm going to subtract 2 from both sides. And that's going to make these 2's cancel out. And then I'm going to be just left with x on the right, and on the left, I have 6 minus 2, and that's going to be 4, and I still have my greater than symbol. Now, this is the part where you have to pay close attention. So I have 4 is greater than x, the answers. Over here, the x's are all first. So my 4 is bigger than the answers. So if I look over here, I need the answers to be the smaller one. And so here it's saying the answer's x is less than 4. So this choice here is making the answer smaller. And so the way you can think about that, if you want to think about it as a rule, if you flip x and 4 sides, then you have to flip the greater than to a less than in order to write the x first. So that's just an extra step that you have to remember. And you just remember, think about it as, okay, if here in my answer the x's are the smaller one, it has to be the smaller one no matter what side it's on. All right, so here I'm solving this inequality. I'm going to draw my line to keep my side straight. And on my right side is where my variable is, which is okay. And I have a 4 times y. So to undo that multiplication, I'm going to have to divide both sides by 4. And so these are going to cancel out. And I'm going to be left with just y. And then I still have my less than symbol. And then on the left side, 12 divided by 4 is 3. So here, it wants to know which of the values here is going to make this true. So which of these can I put in for y and it'll be true? So if I put in a 3 instead of y, is 3 less than 3? No, they're the same, so it can't be 3. If I put a 2 in for y, is 3 less than 2? No, 3 is bigger, so it can't be 2. If I put a 4 in for y, is 3 less than 4? Yes, that one's true, so it's most likely going to be C, but I always like to check all of them. So I put the 1 in for y for letter D. Is 3 less than 1? No. So that means C is going to be my final answer. Here's another problem where they give us the inequality and then we have to show the answer on a number line. So I just rewrote the problem over here to make it easier for me to solve on the screen. And so here I'm going to draw my line to keep my side straight. And I have 60 times x. So to undo that times, I'm going to divide both sides by 60. And I'm using a fraction bar to represent division. So here, these 60s are going to cancel out, and I'm just left with x. I still have my less than symbol. And then 4,800 divided by 60 is 80. And if you need to go over here and, off to the side, work that out as long division, please do that. There's no harm in that. You want to get the answer right. And so now I have a less than symbol. So my less than symbol, that means I'm going to have an open circle and I'm going to be shading down to the smaller numbers on my number line. So I'm looking for an open circle over 80, which I have in C and D, but I need to be shading down. So that's going to make my final answer here D. Here I have another inequality to solve. And I just rewrote it off to the side so I had room to work it out. Here I have 1 over 33 times x. So to undo that, I'm going to divide both sides by the 1 over 33. And so that's going to cancel out, and I'm just going to be left with x, and I still have my greater than symbol. But remember, when you're dividing by fractions, that means the rule for dividing by fractions is that you change it to multiplication and flip the second fraction. And so in order to work that out. So here, I'm going to put in 1 underneath 84. And then I'm going to have to take 84 times 33. And once I work that out, that's going to be 2,772. And then 1 times 1 on the bottom is 1. Which is, when you have a 1 in the denominator, you can just drop that. So it's going to be 2,000, x is greater than 2,772. So since it's a greater than, that means I'm going to have an open circle and shaded up on my number line. So I'm looking for an open circle over 2,772. So that's in B and D, but it's greater than. So I need to be shading up towards the bigger numbers. Going to make my final answer D. So here I just rewrote the inequality and I went ahead and dropped the parentheses since there's no numbers before or after it. And here my x is being divided by a 4. So to undo that division, I'm going to have to multiply both sides by 4. And so that cancels out the 4's on the left side, and I'm just left with x. And then I still have my greater than or equal to. And then on the left side, 3 times 4 is 12. So that's going to be my final answer, which we see in choice B. This problem is probably one of the trickiest ones you might see, but because there's a division here and because the division is divided by our variable, the y, I can't just take times 72 to both sides. To do that, the 72 would have to be second. It'd have to be the divisor. So here, I'm going to have to multiply both sides by y first because y is the second one. And so when I do that, the y's are going to cancel, and I'm going to be left with 8y times 8, which I'm just going to write as 8y is greater than 72. Another way that you might see that is if you change that division sign to a fraction bar for division. If the y is in the denominator, you can always multiply both sides by the denominator, so that's why we have to start with that. And then here, our second step is going to be to divide both sides by 8. And those 8's cancel. And I'm left with y is greater than 9, because 72 divided by 8 is 9. And so here it wants to know what value can I put in for y and make it true. So that just means if I put in 8, 10, 7, or 9 for this y here, which one of those numbers is greater than 9? So I need a number greater than 9. So the only choice here that's greater than 9 is 10. So it's going to make B my final answer. The other type of problem you could see in this section is when you're given a word problem and you have to translate that into an inequality. So in order to do that, you're going to need to know what some of the key words mean. So when we see the words some, more than, plus, added to, and increased by, that's going to mean that we need to add addition. I've starred these two here because they're the two we have to be careful with. When you see more than or added to, the words is going to be flipped from what you write in the equation. So here, 5 was first, it's last in the translation, what you write down. 13 was first, it's going to be last in the part that you write down. A number was last in both of these, and it's first. The subtraction words are less than, decreased by, minus, subtracted from, difference between, and here I've starred less than and subtracted from for the same reason. You have to flip what you see in the words into the equation. So here, 3 and 4 were first, 3 and 4 are last. A number was last, it's first in the translation. Multiplication, our keywords are times, multiplied by, twice of, and a product. Division, our keywords are quotient, divided by, and ratio. And then now we're going to have inequalities. So if we see, and our inequalities are greater than or equal to, less than or equal to. So here we have Amy and Ebony are shopping. Amy has $78. Together, Amy and Ebony have less than $172. So which inequality below shows the amount of money the two girls have? So if I take those two, their amounts, if I take them and add them together, so Ebony's amount we don't know, so we're going to use X, and I add that to Amy's amount, it has to be less than 172. And so where I see that equation is going to be choice A. They just wrote 78 first and X second, which is fine. And that's going to be my final answer. Here's another word problem. When shopping for a baby doll for her daughter, Ms. Martin found the price of 4 baby dolls was less than $70. Which of the following inequality represents this information? So here, she has the price of 4 dolls. So if I take 4 times the price, which we don't know, so we're just going to use B, and then I know that has to be less than $70. And so the answer that shows me that equation is choice C. This problem here is we're just straight translating from words to inequality. There's no word problem. So here we have 3 plus a number, plus means addition, and a number, we're just going to use the letter N, is greater than, so I write a greater than symbol, 6. And so there is my inequality, which is choice A. My last one here that I'm going to translate is I have a number minus 2. So a number is n, minus is subtraction, and 2 is 2. And that's going to be is greater than or equal to. So I'm going to write the greater than or equal to symbol. 4. So I write the number 4. And then the answer that shows us that inequality is choice D. Thank you for joining us today, and I hope you learned something new.